Okay, so now we get to do the truly bizarre thing. I think this is truly bizarre. So this is called composition of trigonometric functions and their inverses. So in other words, you're going to have cos and inverse cos, and tans and inverse tans, and sines and inverse sines. And we're going to look to see what happens. So the first thing we're going to look at is evaluating the cos of the inverse cos. So we're going to look at the composition, something like sine of the inverse cos, which means the sine of a number whose cos is x. Anyway, what they're going to do is they are going to ask you to evaluate. So for these types of questions where it's the cos of the inverse cos versus the inverse cos of the cos, you have to always make sure that the ratio that's given is in the domain of the function. So let's look at the domains. So the domain of inverse cos and inverse sine was the same. It was -1 to 1. You can't get answers for inverse cos or inverse sine outside of that because they don't exist. And then the domain of the inverse tan function was really anything, right? It was -infinity to infinity. Okay, so what does that mean? Well, they're going to be asking you questions like this, and it's going to say, take the cos of the inverse cos of √3/2. Now, in my head, I'm thinking, well, cos and inverse cos are kind of like square and square root, or multiply and divide. They undo each other. So will my answer just be √3/2? Well, let's check. So first thing we would evaluate is the inverse cos of √3/2. So if I was to draw in my restricted range, right, √3/2 can only be in quadrant 1. This would be adjacent over hypotenuse. So it's my 1, 2, √3 triangle. Now it doesn't matter whether I do this in radians, degrees. Most people like degrees. So I'm going to say that my angle is 30 degrees. But then look what it's asking me to do. It's now taking the cos of 30. Well, the cos of 30 is adjacent over hypotenuse. It's √3/2. Seems like a bit of a silly question, right? Let's move on to tan, see if it's the same. So the first thing we would do is find the inverse tan of 1. Well, the inverse tan of 1, right, it's positive, so it's going to be in quadrant 1. We've got opposite over adjacent being 1, 1, so it's my 1, 1, √2 triangle. So my reference angle is 45 degrees. Well, now it's asking me to take the tan of 45 degrees, which is opposite over adjacent, which is 1. Cool. So then people get in this routine. They're like, oh, it's the inverse tan, or the tan of the inverse tan of 1 is 1. The cos of the inverse cos of √3/2 is √3/2. And so they're like, oh, the cos of the inverse cos of 1.8 is, oh. Just be careful. It's the only rule with these is that don't answer 1.8 because it does not exist, right? There is no value of the inverse cos of 1.8 because the restricted domain is -1 to 1. So you would just say does not. Okay, now we're going to do the opposite. So is this going to be the same? Well, we're taking the tan of pi/6 and then we're taking the inverse tan of that ratio. So it should be. The only thing we have to make sure is that now that the angle is in the range of the function. So what we could just do is check ahead of time, right? I don't know why I'm writing cos first all of a sudden. So we've got sine, cosine, and tan. So the restricted range for sine is -pi/2. That should be a square bracket. Square bracket, -pi/2 to pi/2. For cosine, it's 0 to pi. And for tan, it's -pi/2 to pi/2. Okay. So the first thing we check is pi/6 in the restricted range? Yeah, so the answer should be pi/6. Now, if you want to check it, just draw it, right? Pi/6 would be your 1, 2, √3 triangle. So the ratio would be opposite over adjacent. So you'd be finding the inverse tan of 1 over √3, which would be pi/6. Okay, so then you start getting on this roll. You're like, cos of 3π/4. Well, 3π/4, is that in the range? Well, it's between 0 and 4π/4. So yep, so the answer should be 3π/4. So let's assume it is. Okay, and then we can keep going with this one. And we're like, okay, so now we've got the inverse sine of 3π/4. Now, whoa. The restricted range of sine can only go up to pi/2. Pi/2 with a denominator of 4 would be 2π/4. So this is too big. So what should we do? Well, let's figure it out. So if I was to find out what the ratio is for 3π/4, we know it's in quadrant 2. We know its reference angle would be pi/4, so it's my 1, 1, √2 triangle. Now, check for negatives, right? It would be -1 over √2. So if I find the value of the inverse sine of opposite over adjacent, or hypotenuse, which is 1 over root 2. Now, if I asked you to find the inverse sine of a positive ratio, what quadrant would I give that would be in the restricted range? It would have to be in quadrant 1. In other words, I'm not going to give 3 pi by 4 as an answer. I'm actually going to give pi by 4 as an answer. Now, could you check this with a calculator? Well, let's try. Okay, I'm going to put my calculator in degrees and expect a 45-degree angle as an answer. So I'm going to go inverse sine of 3 pi by 4. And what did you get? You get it? Spot my mistake. So if you're plugging it into your calculator, I had a pause there. I was like, oh no, I'm doing it wrong. Because I just wanted to check that I get the right answer in degrees, and I know 45 degrees. If you're going to have your calculator in degrees, don't put in 3 pi by 4. So you have to go inverse sine of 180 minus 45, which is what? 135? And then I get 45 degrees. So we've done it correctly. So the only thing to check with these ones is that whatever angle they give you in here is in the restricted range of your function. And then lastly, they're going to just combine trig functions. So this one you can't undo, like sine doesn't undo tan and cos doesn't undo sine. So you have to actually do these ones. So for this one, this would be the sine of the inverse tan of -1. So we have to figure out where that would go. So it's -1. So the restricted range for tan is negative pi by 2 to pi by 2. So tan is negative in quadrant 4. Okay, so we know we're dealing with our angle being down here. So to get a tan of 1, it's my 1, 1, root 2 triangle, 1, 1, root 2 with a -1 here. All right, so the value of the inverse tan of -1 is my 45 degrees, but it's going to be negative. So negative 45, or negative, let's go pi by 4. Let's not be afraid of radians. So then what you would do is find the sine of negative pi by 4, which you'll already have your triangle drawn, and it would be opposite over hypotenuse, so -1 over root 2, which we would then rationalize the denominator, and we get negative root 2 over 2. Okay, pause the video and see if you can get this last one. Okay. So you're going to take the inverse cos of whatever you get of the sine of pi by 2. So the sine of pi by 2, right, is in the restricted range, and it would be up here. So the point here is 0, 1. Okay, so the value of sine of pi by 4 is y over r, or 1 over 1. So it's just a 1. So then we're trying to find the inverse cos of 1. Well, cos doesn't equal 1 at the same place sine equals 1. So let's look at a cos. And again, we want to look in the restricted range. And where does cos equal 1? Well, cos equals 1 when x is 1. So it would actually be here at 1, 0. So the answer for this one would be 0 degrees or 0 radians, whichever one. All right, so hopefully those feel clear as mud. They are a bit weird, but they are doable with the knowledge that you have. Good luck.